So we're about to start. Thank you all for participating in this side event. Italian delegation is pleased to present you a side event on cryosphere of the third pole and the role of Italian cooperation in aligning with WMO priorities. This is also under the kind hosting of WMO Secretariat to have this side event during the Executive Council. And then it's my pleasure to introduce you the Italian His Excellency Ambassador Vincenzo Grassi for the welcome address. Ambassador.
Well, thank you very much, Secretary General, dear guest. It is an honor to address this esteemed assembly at the World Meteorological Organization. As a nation, Italy is defined by its mountains, coast, and deep scientific heritage, views climate change not as a distant threat, but a lived reality. Our glaciers in the Alps are shrinking. Our permafrost is retreating. These are not just signs. These are calls for action. Well, before listening to the very important speakers and the rapporteur we have today, just three small considerations on three topics that are important for this side event: Italy and cryosphere, high mountains meteorology, climate change, and alpine actions. Italy stands at the crossroad of the Mediterranean and Alpine regions and thus play a unique role in observing and understanding cryospheric processes in temperature latitudes. We are home to over 900 glaciers, many now in rapid retreat. The Italian Glaciological Committee, with over a century of history, continues to monitor these changes, contributing data to global cryosphere assessment. We are active members of the Global Cryosphere Watch and participate in major initiatives on glacier monitoring, permafrost mapping, and snowpack evolution. Second point, high mountains meteorology, science, and altitude. Our Italian Air Force Meteorological Service, which is an excellency of Italian scientific prestigious excellence, together with the National Research Council and IVCAP2 CNR Consortium, operates weather and climate station in the Alps and beyond, including the iconic Pyramid Laboratory at the Everest Base Camp. Italy leads in remote sensing, automated weather station, and integrated forecasting in complex mountain terrains, offering expertise to countries vulnerable to high-altitude climate risks. Our meteorological research supports avalanche forecasting, water resource management, and disaster preparedness, all critical in mountainous regions where lives depend on accurate, timely information. This is also why we are an important actor in UNDRR programs. Finally, on climate change and alpine action, Italy has placed the cryosphere at the heart of its climate diplomacy. In 2021, during our G20 presidency and the COP26 co-partnership with the United Kingdom, we emphasized mountain ecosystem and launched dialogues on climate adaptation in the Alps and Apennines. We support transnational research under the Alpine Convention, the United Nations Economic Commission for Europe, and contribute to the WMO regional climate centers. We are also advancing climate services for the Alps, supporting farmers, civil protection authorities, and local communities facing intensified climate variability. Italy believes that science, solidarity, and shared data are the foundation of effective climate actions. We reaffirm our commitment to supporting the World Meteorological Organization and its members in understanding the cryosphere, improving mountain meteorology, and building resilience in the face of a warming planet. Let me conclude in thanking again General Baione, who is a major actor, national and international, on these topics, and who is a fundamental actor also in raising awareness in Italy about the importance of sustainable development goals and sustainability actions of the government. So thanks again to the speakers that we are going to listen, and I hope these will contribute to reflection on these very fundamental topics. Thank you.
Thank you, His Excellency. And then we have the a recorded contribution by the third Vice President of WMO, Permanent Representative of India, Dr. Mohapatra, who sent us an opening remarks, and I will show you briefly on the screen, also with the recording. Okay, we should have. Okay.
Namaskar, good evening to all of you. The Great Himalayas are popularly known as the third pole, considering the physiographical and climatological features similar to the north and south poles of the Earth. It encompasses over 5 million square kilometers with an average altitude of over 4,000 meters above the mean sea level. There are about 100,000 glaciers throughout the third pole. It hosts the largest ice mass outside the polar regions. The third pole spreads across 12 countries, including Afghanistan, Bangladesh, Bhutan, China, India, Kazakhstan, Kyrgyzstan, Myanmar, Nepal, Pakistan, Tajikistan, and Uzbekistan. More than 2 billion people depend on its resources within and around the third pole regions. With a warming rate higher than the global average, the region is identified as one of the most vulnerable regions on Earth. Extremes in precipitation increased over the third pole region in the past century. Annual mean daily precipitation increased significantly and positively correlated with the elevation. The projected warming could significantly change the third pole's atmospheric heat source and sinks, which would further impact Asian monsoonal system. Even though weather forecasts are challenging in the third pole, it is also the time to start the climate services. India has been assigned the mandated responsibility of operational data services to support the operational long-range forecast and climate monitoring over the third pole. IMD will develop quality control regional climate data sets, graded wherever applicable. Apart from this, IMD will also contribute to climate applications, training, capacity building, research, and development in the third pole region. So thank you very much.
Okay, and now I will introduce you the next speaker, which is Dr. Sulagna Mishra from WMO, Scientific Officer of Hydro, Water and Cryosphere, to give us a framework related to International Year of Glaciers Preservation. And just a second to share your presentation. Okay, just full screen. Okay. Yes.
Thank you, Antonio. Good evening, everyone. It's a pleasure to be with this panelists. I would give a quick update of WMO's role so far in the implementation of the International Year of Glacier Preservation 2025, and what are the perspectives of the year that is relevant to WMO. In December 2022, the UNGA, the United Nations General Assembly, declared 2025 as the International Year of Glacier Preservation, and the mandate was given to UNESCO and WMO together to co-implement this, implementation of the international year. We started the preparation somewhere in the mid of 2023. Started with a brainstorming session of how we should implement the international year, because the mandate also came with a huge responsibility, however, very little funding. The International Year declaration said there is going to be a trust fund, and we have a trust fund that is set up in UNDESA, which has received some seed money from Tajikistan, and a few other countries have showed interest. Just to highlight that all the implementation and the act and the results that you are going to see so far has been pretty much crowdsourced and voluntary based from our member states and organizations that have been a part of the initiative so far. The WMO and UNESCO, we set up a secretariat for the International Year of Glacier Preservation Implementation, and we formed 4 task forces, and we launched an expression of interest for organizations, member states, scientists, people from all walks of life who work in the sector of cryosphere and would like to contribute to the International Year and would like to be a part of it, to be a part of the initiative. Happy to report that we have 340 plus members. By members, it's individuals, countries, organizations, UN organizations, NGOs, academia, and so on, who are a part of these 4 task forces. Based on the different kinds of activities that they contribute to, or the kind of activities that they have committed to the International Year, we have divided them into 4 task forces. One is on advocacy, the global campaign. We have one for a regional workshop, capacity building programs. We have the third one for research and monitoring initiatives, and the 4th one for policy advocacy, partnerships, and resource mobilization. All of them have leads and co-leads, and we also have an advisory board, which is an overarching body which looks at the implementation, the overall implementation of the International Year. It has 2 experts who are the leads, the co-leads from WMO and UNESCO side, leads from the task forces, and 16 other members who then together form the advisory board. Very quick recap of what we have done so far. We are halfway through the year, and I would just like to highlight a few success stories of what we have achieved so far. Even before we launched the year, which was launched on the 21st of January, we did a master class for journalists. Why we did this was we did an initial survey to understand how much journalists understand about glaciers, and these are journalists who report on climate science, climate services, climate change, and 70% of them reported that they know nothing about glaciers. So we said, you do nothing or little bit, or we gave a percentile, and they said 70% of them said we know nothing. So it was absolutely necessary that we did a masterclass where we said we give them an scientific overview of what are glaciers, why are they melting, what we can do about it, and also bust the myths around or the wrong information that is circulated around glaciers. We had more than 300 journalists who participated in this event, and it was to our surprise that 200 of them stayed over for the whole 2 hours, and we got almost 100 questions. So it just showed there was massive interest from the journalist community to know about glaciers, and this was done even before we started we officially launched the year. We launched it here in WMO in Saliobasi, both online and offline. It was very well attended. And at the same time, we also did side events. This was also crowdsourced and completely voluntary-based side events. And it lasted the whole day. We had 33 side events that went on parallelly. And it just showed how much interest people had and organization had to be a part of the International Year of Glacier Preservation. I just in the to add to this, apart from the launch that happened on the 21st of January here, we also had 2 other major events. One was in Paris and one in New York. This was for the World Met Day, World Glacier Day, and the World Water Day. And we dedicated this to the topic of glaciers. The World Water Development Report on the theme of glaciers was released, and we showed the website, everything that was done. And we received around 1.2 billion hits or impressions on social media, and more than 10,000 articles and news pieces were written about glaciers. Our media and comms team sitting in the back there, they were very happy with this success. So this masterclass that we did in the beginning was really very important to make sure that we are heard right, and what is being reported about glaciers is also done in the right light. The last event that we just finished a couple of weeks back was the high-level International Glacier Conference that was hosted by the government of Tajikistan in Dushanbe. The three major outcomes that came out of this was the Dushanbe Glacier Declaration, the summary of the conference, as well as a call for action, which is called the Dushanbe Glacier Appeal. This is a document that is still under progress. The secretariat of the conference is putting together all the commitments and not just actions, but projects and financial commitments that were made during the conference. And it will also be an open call for member states and organizations to continue to contribute to this call of action and register their commitments there. You can see Celeste, our Secretary General, here with the President, and in the opening ceremony, ASG was also there in the closing and in the final press conference, which was quite impactful. We had a room full of journalists, and WMO's role was also that we not only participated in many side events, but we also led three of the official forums there: one on monitoring, one on research, especially on early career research, and one on early warning for cryosphere related services. We made it very sure to quote once and again that the role of NMHS and WMO cannot be overlooked when we are talking about monitoring or data or early warning systems. And even when we were not in the room, people were quoting WMO and the NMHS and their role. So we were happy with this outcome. This is my last slide. What I would like to highlight here is what we are doing now as we are the International Year Secretariat as well. So what we are doing for wrapping or looking forward, and how these things are, or some of them are relevant to WMO. We are going to report the outcomes of the year, the success indicators of the year, to the UNGA, but we are also keeping a very close eye on the number of collaborative or knowledge sharing initiatives that happened during the year, what are the different kind of events that was done, and how they can directly contribute to WMO members. We are also looking at the new glacier and mountain cryosphere policies, how many new indices mention glaciers, how many sustainability measures were adopted that can be attributed to the international year, a number of scientific discoveries, publications. We are closely looking into that as well, and how much financially, how much resources and funds were raised during the year, and how WMO and member states can benefit the maximum of this. In one of the sessions that we were in, it was by ADB, and they were defining how a glacier project can be identified. So they are getting so many new proposals now that they need to create this new category called glacier project. For WMO, we have the strategic objective 1.5, which was passed in the last Congress, which the idea is to accelerate the development of integrated systems to look at and address the global risks that are associated with cryosphere and the changes in cryosphere and downstream impact. We, under the CIRCOM, have established a JET Cryo, a joint expert team for cryosphere, under 2 standing committees, and the JET Cryo at the moment is working very hard on a white paper for setting up priorities for cryosphere related services, and the idea would be to finalize this and distribute this before the end of the year. Thank you.
Thank you very much, Sulagna. And then I will introduce Brigadier General Luca Baione, member of Executive Council and permanent representative of Italy with WMO, to introduce the speakers. Thank you.
Yes, thank you, Antonio, and good afternoon, everyone. Few words from my side before giving the floor to the speakers just arrived from Italy. To give you the flower which is behind this initiative, I would borrow the motto of the 75th anniversary of our organization, Science for Action. Indeed, what are we going to listen to? It is what Italy is putting on the ground as actions for science and actions by science. In this regard, let me address you as with a word which has a peculiar meaning from the Italian side, which is colleague. Colleague comes from the ancient Latin language, which means cum legare, and indeed it is the way to say people who are joined to pursue the same commitment. And therefore, here I'm very happy to address you and address my colleagues here in the podium with exactly this word, cum legare. And another point I like to raise is that what we are going to listen to about the Italian research in the third pole, in the cryosphere of the third pole, is exactly in line with the words of our constitutions. It is remarkable that in our constitution, the environment and scientific research and the preservation of the cultural heritage, they are in the same article. Article 9 of the Italian Constitution obliges the government, the Republic, to safeguard the environment and to promote scientific research. This is exactly what we are going to listen to. In this regard, our colleagues will speak about basically 5 issues. The first is atmosphere and climate. Second, glaciers. The third, water resources. The fourth, biodiversity. And finally, environmental medicine and health. I'm sure you will be benefit by these presentations, and without going further, I'm very happy to give the floor to Dr. Diolaiuti, and I ask her to introduce herself with regard to her present position and her role in the research in the cryosphere of the third pole. Please, Adele, you have the floor.
Thank you very much. Good evening. I'm delighted and I'm honored to be here and to present you our research on the high mountains and the third pole. I am Guglielmina Adele Diolaiuti. I am a full professor of the University of Milan, the State University of Milan. Since the last 20 years, I'm working with the VKH-CNR, that is an NGO, who is devoted to study high mountains in high mountain Asia, but not only, performing technical and scientific research and managing several cooperation projects. I was part of this project during the last 20 years, and today I can share with you our research. My presentation aims to review the cryospheric research conducted under Italian coordination or with the participation of my country in the high mountain areas of the planet and also in the third pole region. In fact, there is an urgent need for WMO to develop an experiment program to be conducted in these regions in order to collect, to manage, to standardize atmospheric, meteorological, and glaciological data in high-altitude glacial mountain ranges in Asia, also known as the third pole, but also on high mountain regions in several areas of the planet. Italy has a significant experience and existing data resources in these areas, providing a solid basis for this kind of initiative. EVK2CNR has a strong and robust monitoring strategy. We are working on several key areas, key high altitude areas of our planet, in Asia, in South America, in Africa, in the Alps. In these regions, we are working under the umbrella of several international cooperation projects. We generally share our results and our data thanks to a geoportal that is open, and so it's possible to obtain data, information, and to use our results. The main aims of the program should be to aggregate high mountains and firth pole atmospheric and glaciological data, to develop best practice guidelines for instrument installation and operation in remote areas, to test innovative monitoring instruments suitable for extreme environments, and to establish a consortium for data sharing and open access under the WMO auspices. Presently, the largest part of people and scientists in the world know that high mountains and the firth pole are really important, and that is important to survey and to study glaciers in these areas. In spite of this general and recent interest, we like to underline that the Italian interest and attention on these glaciers started more than 70 years ago. An example is Ardito Desio, who visited Karakoram in the 20th of the 19th century, and he led the expedition who reached the summit of K2 in 1954. More recently, EVK2CNR organized and led under the umbrella of several scientific projects investigation in selected key areas of the high mountain Asia and the firth pole. Moreover, it is also important to remember that glaciers in these high mountain areas of the planet are really water resources. This is a photograph taken by a PhD student of mine in the Bagrot Valley in Karakoram. In this picture, you can see children that instead that going to school, they every day go with some adults to the glacier to take some ice blocks, to melt the ice blocks in the village and to obtain fresh water, drinkable water, and for civil use. So in some areas of the planet, glaciers are really crucial water resources. For all these reasons, my organization and the EVK2CNR try to produce a strategy for monitoring glaciers on high mountain areas of the planet, on the field and from the space. Let's start from the space. From the space, that is to say, using remote sensing investigation. We applied the remote sensing investigation to produce glacier inventories. Glacier inventories are glacier database useful to describe geometry and surface features of glacier in a region or a nation. We started in 2016 from the Central Karakoram National Park, a wide protected area of Karakoram. We produced the Central Karakoram National Park Glacier Inventory, describing 608 glaciers, covering about 3,700 square kilometers. These data were useful to obtain an evaluation of the glacier volume by applying an indirect approach. And we also applied a multi-temporal analysis which permitted us to find evidence of surge-type phenomena. A surge is a glacier advance not linked to climate change, but instead caused by an irregular ice bedrock contact condition. Moreover, our multi-temporal analysis permitted also to evaluate a quite stable condition of the largest part of glaciers in the Karakoram, thus confirming the Karakoram anomaly. Moreover, together with scientists from Pakistan Meteorological Department and together with other international scientists, we also analyzed climate variables, looking for climate driving factors able to explain the Karakoram anomaly. And we found, for example, increased winter precipitation and decreased summer temperature during 30 years in the largest part of Pakistan, thus partially explaining the Karakoram anomaly. And more recently, we are analyzing satellite images to describe snow cover variability always in the Karakoram. Under the umbrella of the Glacier and Students project that is funded by the Italian Agencies for Development Cooperation and is executed by United Nations Development Program and implemented by EVK2 CNR, together with several Pakistan partners, we produced the new Pakistan Glacier Inventory. We were able to describe 3,032 glaciers, a very large, wide, huge number of glaciers. We analyzed the Sentinel-2 satellite images, and we performed a segmentation approach by including students from Italy and Pakistan. This for us is very important. In fact, we always pay attention in performing educational and learning project involving local students, because for us it's very important to create locally technicians and scientists able to continue our research and to maintain the results. The new Pakistan Glacier Inventory permitted also to describe some particular phenomena, glacial risk phenomena, as this surge occurred in 2022, which destroyed the bridge in Pakistan. Moreover, we also performed several field investigations to complete our monitoring strategy. In the Alps, we started in the Alps with an automatic weather station that is inserted in several WMO programs, GWEX, SPICE, and now presently OSCAR. So we are part of WMO with this automatic weather station in the Italian Alps that is working without interruptions since the last 20 years on a glacier. We have also automatic weather station at the surface of glaciers in Pakistan, on the Baltoro Glacier, since 2004 at Urdukas, Concordia, Ascole. More recently, thanks to Glacier and Students project, we installed automatic weather station in the Unza Valley, again on the Baltoro Glacier. We have also benchmark in Nepal. In the Sagarmatha National Park, there is a scientific laboratory, the Pyramid, where are present atmospheric and meteorological stations. And also on a small but meaningful glacier, Chengrinap, we installed an automatic weather station that was useful to describe meteorological and energy conditions at the glacier surface. Some data, just to have an idea that the automatic weather station are working and are collecting data. Data were useful to support our research, to produce solid papers also published on Nature, and to look for correlation with, for example, black carbon deposition. Our albedo data are really important to look for black carbon deposition at the surface of glaciers. Moreover, data from automatic weather station are crucial to as input data for our melt model. We, for example, applied the distributed melt model to describe melting over the 600 glaciers in the central Karakoram National Park, and we are starting to do the same on the 13,000 glaciers of Pakistan. So for us, it's very important to have data collected on the field to calibrate and validate our models. We also visited glaciers to acquire information and data on ice ablation, to install the hydrometer in order to measure meltwater runoff for melt stream fed by snow and ice melting. And always during these field campaigns, we include students, Italian students, for example, PhD students and postdoc that can complete their formation on the field, and Pakistan and Nepalese students to make more robust their preparation in the field of environment. Last but not least, we are not only paying attention to climate and glacier, but also to pollution. You perfectly know that glacier ice derive from snow precipitation. So inside the glacier ice, you can find pollutants, for example, micro and microplastic. We were the first to find microplastic on glacier ice in 2017 on the Alps. Then we visited the Arctic, Patagonian, and Asian glaciers, and we found microplastic on all these glaciers. So on all the glaciers we visited, we found pollutants derived by human activities. So it's very urgent now to prepare guidelines and protocols to standardize these kind of measurements. Then, Italy has already done remote sensing surveys, field campaigns, installation of permanent instrumentation, and training of learning projects. Presently, we are working under the umbrella of Water for Development project to evaluate meltwater and its availability in several areas of Asia. We are also working under the umbrella of Spantik Lab project, that is a 3-year project aims to focus on Chogolugma Glacier, flowing down Spantik Peak. It will be an open-air laboratory for studies on glaciers, water and air quality, and also the nexus, the links between these elements and human health. And we are ready to go on this area on the next weeks with our team. What we have to do in the future? Surely in the future we need to repeat periodically remote sensing surveys to update our glaciological database. We need to perform new field campaigns. We need to maintain the installed permanent instrument to record long sequence of cryo, air, and weather conditions. We need to develop new training and learning projects for growing local scientists and technicians. And we need to share with all of you our data and to collect your data to put all together in a unique database, in a unique geoportal. Thank you for your attention.
Thank you, Adele, for this impressive presentation, which gives us, in a nutshell, the idea of the effort of the Italian scientific community with regard to glaciers monitoring, especially in the third pole, but we have seen not only in the third pole. Now I give the floor to Angela Marinoni, as soon as the presentation is ready. Angela, the floor is yours.
Thanks, Luca. So I'm presenting now the atmospheric activities related to the cryosphere on the third pole. So I'm from the National Research Council of Italy, that is the largest public research institution in Italy, and is the only one directly under the University and Research Ministry that performs multidisciplinary activities. And then Guglielmina already showed all the EVK2CNR is a recognized association that since 35 years manages scientific and technological research at high and extremely high altitude, with a special focus on the areas belonging to the so-called third pole. This well-established collaboration allowed us to study the processes affecting the atmospheric composition variability, their impact on cryosphere, and water availability in such critical region like the Himalayas and Karakoram that stands in an area where billions of people live. So these activities are challenges to go from scientific questions to long-term observational capabilities in order to ensure the understanding of atmospheric and climatic processes. One of the pillars of our joint research activity was the establishment of the Nepal Climate Observatory at Pyramid that was built up in 2006. It is at 5,079 meters. It became a global station in 2010. And during 10 years, it allows us to continuously measuring the atmospheric composition in the High Himalaya, to study the sources, the transport mechanism, and the impact on climate and air quality. This year, in 2025, we are restarting the observational program. We already have some instrument working since 1 month, and we have a plan to being back to be fully operative in a couple of years. A special focus of this climatic observatory is on short-lived climate forces like atmospheric aerosols, especially the absorbing aerosol fraction and ozone, that we know can reach high concentration in even at high altitude, with severe implication recognized for human health, ecosystem integrity, but also on regional climate impact, especially for what concerns the hydrological cycle, water availability, and monsoon regime and cryospheres. These are the 33 global stations in the world. 5 of them are in Asia, but only 2 in the inland continent. So we see Asia is a very populated region, but undersampled by atmospheric point of view. Both stations are in the high altitude, so that is very representative of the background atmospheric condition, but it's also important to compare our data with other non-GO stations like Namco on the Tibetan Plateau or Mukteshwar in the northern India, that are also high altitude stations. The key urgent scientific challenges are linked to questions like what are the impact of pollutants on climate, on the Himalayan cryosphere, but also which is the impact on air quality of Khumbu Valley, but in many valleys of the Himalaya and Karakoram. Which are the interactions between the variability of Himalayan atmospheric composition and the Indian monsoon system. Specifically, our scientific goals are to study the seasonal and interannual variability of the short-life climate forces in the Himalayan region, study which is the anthropogenic and natural sources, to investigate the pollution transport mechanism to the high altitude area, including the role of valley transport of the atmospheric brown clouds, and study the pollution impact on climate at regional scale on air quality and cryospheres. These are the essential climate variables observed continuously during 10 years. They span from several aerosol properties, including chemical, physical, and optical properties, but also gas concentration and meteorological parameter. We already restarted with a part of the particle number size distribution, and by the end of the year, another field campaign is foreseen to enlarge these variables monitoring. These are our main results. So we improved our knowledge on the net seasonality of atmospheric composition and variability in the high southern Himalayas. We observed systematically some acute pollution episodes at very high altitude, especially during pre-monsoon seasons. We understood better that the Himalayan valleys represent a direct channel for transport of pollution toward the Himalayas, also triggering secondary aerosol formation that can reach longer lifetime in the free troposphere. We also see that fires in South Asia play a significant role in the occurrence of high-altitude pollution events. The large atmospheric circulation play also a role in triggering the monsoon start, and also stratospheric intrusion were frequent, playing a significant role in modulation of ozone and black carbon concentration, especially in winter. Pollution transport toward the Himalayas impact the direct radiative forcing, but also the snow and ice albedo, with several implications on the cryosphere survival. We also studied the Asian baseline of halochlorofluorocarbons. The baseline is consistent with other measurement sites in the world, like, for example, our station in Italy. The scientific results include several scientific publications. First of all, one special issue on atmospheric chemistry and physics, other papers on PNAS, GGR, the cryosphere, Nature Geoscience, many outreach broadcasts on TV, but also the involvement of local community. And one example is this draw contest that was set up for one World Environmental Day, and children from several schools in the Khumbu Valley participated to this draw contest. So remote regions like the high mountains represent suitable location to study background atmospheric processes. But there are several issues related with performing continuous scientific measurement at very high altitude. These issues are related with difficulties in installation of permanent stations that often are unaffordable because of absence or low discontinuous power supply, need for in situ personnel that it's difficult to find, severe or unstable meteorological condition, requirement for specialized monitoring. For this reason, scientific activities in remote high mountain regions are still limited, and this represents a limitation for a better investigation of climate and environmental processes. Together with the VK2CNR, we have some project that allow us to new technological development. Here there is 2 examples that were developed in the frame of national project financed under the umbrella of Next Generation EU and Chieti University. The first is ARES, the Autonomous Remote Environmental Station, and the YEMS, an indoor health and environmental monitoring system. The first one is dedicated to the outdoor atmospheric composition, and the second one to the indoor with also some medical parameters. In the next summer, ARES will be deployed in the Karakoram. It is now under testing phase at Montecimone Station, another Go Global station in Italy, at 2,000 meters, and at the beginning of July it will be employed for a long field campaign near the Chogolungma Glacier in the Karakoram region, in a region higher than 3,000 meters. And the second unit will be installed on the southern Italian Apennines. This study is a follow-up of a previous study carried out in Ascole in Pakistan in 2014, where we studied the influence of local emission at this mountain village of Ascole during a summer field campaign. The second technological unit, the YEMS, will be developed in an area nearby Narandu, near Spantik Lab area, in the frame of British Karakoram project. The unit record both personal medical parameters as well as the indoor atmospheric composition, air composition, so the indoor air quality. And this also represents a follow-up of a previous study published in 2018, in which we found a relation between the indoor air pollution that can reach very high level of particulate matter and black carbon concentration in these in the rural houses where biomass fuels is used even in open fires. And we found an association between indoor pollution exposure and the effect on lung and cardiovascular health. To conclude, we also have a new plan for drilling ice core in Karakoram to put in connection the actual atmospheric composition and the environmental and climatic archive that are stored in glaciers. So, thanks for your attention.
Thank you, Angela, for the insight you gave us with regard to the Karakoram region, with all measurement conducted by the Italian scientific community. But what I want to pick up from your presentation is another point, the point of resources which are dedicated to this activity. In these very days, we are speaking about resources, and I have to say that Italy, the Italian commitment spans from resources dedicated to the international organizations as well as resources to fund bilateral and multinational initiatives. And I want to pick up another point which was referred to also in the first presentation, the involvement of young generations. This is a problem which will be of long-lasting nature, and therefore the involvement of young generations is paramount for us. Within also the Youth for Climate initiative we took 2 years ago. And in regard to the involvement of young generations, I see online Professor Pirni, who is going to give us a different perspective, let's say from the social and philosophical perspective related to the climate change. Professor Pirni, you have the floor.
Thank you, General Baione. Thanks to all the World Meteorological Organization initiative and also the hospitality for this talk. I am not in my best conditions, as you can see. I'm in my plan because the previous one was delayed. Let me try to no. Well, I don't know if I can go further. Perhaps I have to renounce to present my speech because I have they started embarking the flights. Let me just try if I can do back to in 5 minutes, or otherwise General Baione have to renounce the intervention, and thus I can leave the slide for your further evaluation. I'm sorry about that, but it's not for my own responsibility.
Okay, no problem. We understand you had travel problems and travel connections.
Let me try.
And
try. If you wish, I can try.
Okay.
Let me try to limit my point. If the audio is quite good, tell me if it's quite good. If I can go further or not.
Yes, proceed until you have to shut off.
Okay. Let me stay just in a very few slide to stick on a minimal statement. We started speaking about geological memory. We had a wonderful contribution related to the glacial memory. But as soon as we enter into another domain, so let's imagine that we have to combine these physical and non-anthropogenic issues with anthropogenic issues, then what is memory for us? What is memory for humans? And the first view for embracing or entering into this area of questioning is looking at the neural net as a proxy, as a way for establishing layers of messages that are accumulating step by step, generations by generation, experience by experience. This is a schema, and this is what is working on the left side of this slide. But if we start imagining, and that let me very fast run to a kind of core message. If we should start to imagine the difference between geological and glacial memory with the anthropogenic memory, we have to enter, General Baione, in the field that you just announced with your previous introductory words, meaning we do know that the glacial memory has its own intrinsic scientific relevance. We do know about the difficulty for reaching that memory, such a memory, and also for keeping that memory as vivid for the next generations, but how to communicate this memory, how to transform this memory in a kind of vivid message for the living people and for people that are starting from this awareness, that are asked to start imagining behavioral change related to attempts for countering climate change domain. From this point onwards starts the issue and the task, and also the challenge, the transdisciplinary challenge related to the anthropogenic memory. We do have to enter into the neurophysiological basis, the neural network, the psychological models, the cultural relevance. But let me just mention some nuances related to the ethical issue related to that. Well, when we enter into the field of memory, we are used to distinguish many different kind of memory. So short-term memory, eidetic memory, working memory, or long-term memory. Let's stick on the long-term memory first, also in accordance with the need for thinking of the present and the future generation. Then the ethical issue is how to create, how to build up, how to imagine, how to shape memory, how to enforce memory, how to make this memory stable, how to transfer memory, how to transmit memory to other generations. Starting from this, we have at least 3 big issues that in our research we are trying to address. In our research based in Pisa, I forgot mentioning to spend a minimal minute in self-presenting myself as a university professor in climate ethics based in Sant'Anna School of Advanced Studies, Interdisciplinary Center for Sustainability and Climate. Well, we are trying to address 3 basic issues. One is related to a linguistic issue, meaning, and this is also a cultural issue, the intercultural and the cultural intercultural relevance related to the way to which people are used to shape glaciers and to shape their own memory. We listen to very important words pronounced by Indian representative, but also by Pakistan representative in order to give shape to that memory. Then we have to imagine transcultural way for transmitting and transferring that memory that should be delivered in English, for example, so a kind of a universal language, but we do know that no language is neutral. So every language is transferring its own cultural relevance, and this cultural relevance has also an ethical, bring also an ethical relevance, an ethical positioning within it. Then we have to stick on one of the most important challenges, but also enemies related to this memory. So we have to imagine a basic distinction, which is ethically disruptive. So the account basis versus the experience-based behavioral change. Let's imagine that a glacier melted, or we suffered for a strong, really relevant climate change experience. If I can bring to the WMO a good tale of it, well, WMO can be impressive. But if members of WMO would believe by themselves from the first person point of view that experience, well, at that point, behavioral change will be enhanced, will be changed, has intrinsically the opportunity to change its own role. This is the magnitude of relevance that we have to take on, and also look at starting creating what-if scenarios. So really demanding scenarios, but that are also effective for real, already present people that are notwithstanding able to create diachronical scenarios, vivid and operating for future people. So experiencing what-if scenarios has to deal with the final aim of my talk also, but also of my present research devoted to this point. So enforcing memory means moving or trying to give shape to a move against the political and cultural short-termism, which is characterizing more often our political stance and our political position. We do need long-termism and long-term policies and policy platforms, but in order to do that, we do need also a stronger memory which is supporting, surrounding, and sustaining those long-term political programs. So, and this has to do, and this is my final word, this has to do with a genuine transdisciplinary challenge. So saving glacial memory and enforcing ethical memory go hand in hand. So this is a unique task in order to give shape to a scientific account that should be preserved, that should be put at the first level of our political agenda, but at the same level of the same agenda should stay the ethical and cultural relevance. Meaning, if we lose the play and the game and the opportunity to explain and to transfer that memory in terms that are ethically relevant, then we're gonna lose the same meaning of scientific effort, of the scientific research devoted to the glacial memory as such. This is something that we have to avoid, and I do really hope that a transdisciplinary effort will keep us saved from this not welcome horizon. Thanks indeed for your attention.
Thank you, Professor Pirni, and thank you for this stimulating and intriguing perspective, which bridges the human memory with the glacier's memory from the ethical perspective. And indeed, Professor Pirni has the merit to initiate this kind of discussion within the Sant'Anna Advanced School of Pisa in relation with the link between climate change and the ethics and young generations. But what I would appreciate more of your presentation is your adaptability, which is indeed deserves a very, very outstanding appreciation. So
we have to be flexible, General Baione.
Yeah, you are flexible and adaptable. And as we know, adaptation together with mitigation are the two magic words which stand in front of us to inspire our activities. So I think we have some minutes left for comments or questions, curiosity, should you have, and also the speakers are ready to take those. I guess you prefer the reception. No, there is one.
Hi, good evening. I enjoyed your presentations. And I recognize that you do, I'm from Jamaica, so we don't have the direct influence of the glaciers and everything. But yes, we are also celebrating for this year the preservation and World Glacier Day and everything. I just want to ask, with regard to investigations and your studies and your research, is it that you're taking your own activity from, say, the Italian Alps to bring it into that region, or is it that you're going into that region with the hope to learn something more, to also preserve what's happening more locally in Italy and in these Alps?
I think some information were in the Angela presentation. You can take this question.
Yes, so we move from the atmospheric composition point of view, we move from the experience of Montecimone Station in Italy that we share with the Italian Air Force. And we went to study also the Himalayan, the third pole region, because this region is poorly sampled, there is much less knowledge. And so Italy, so through the Italian Ministry for Foreign Affairs, financed this action to study also the third pole region.
Okay, for us it's the same. We started installing, for example, automatic weather station on Italian glaciers, on alpine glaciers, on remote glaciers in order to test instruments and sensor to high altitude without energy supply, having the same problems that you have in Asia, for example. And then when we learn a lesson, we go in the high mountain Asia, performing the same investigation. So for us, the Alps are our house. So for us, it's important also to study our glaciers, but also are important test sites to check the instruments and also people, because you need to be comfortable, to be usual to go on the mountain. So for us, it's a bridge. There is a bridge between the Alps and the high mountain Asia that are our house as well.
Some other question? Okay, before concluding, I just want to... okay, there, please.
I just, yeah, my name is Joshua Campbell from HMEI. Absolutely amazing, the monitoring and measurement programs that you have going on and the research. Just my hat's off to you. I know how hard that is sometimes. I'm wondering, are you carrying some of this research into modeling and forecasting or predicting risks and outcomes, such as when glaciers will begin to disappear, water supplies will dry up, and populations will be displaced? And if so, when do you see, 1 million or 10 million people or 100 million people being displaced in the future?
Okay, yes, we are modeling not really when the glacier will complete their melt. Presently, we model the present melt in order to have an idea of the melt amount and meltwater discharge. We are forecasting the the amount of fresh water deriving from glacier in the future with different temperature and radiation condition, so using different climate change scenarios. In order to evaluate the evolution of the glacier, we need more information on glacier geometry, in particular depth, thickness, because we estimate the volume using the data in the glacier inventory, but are not sufficient. For example, on the Spantik, we will perform a radar investigation just to have an idea of the thickness of the glacier, but we need to perform these investigations on a wide sample of glacier in order to apply a full model, three-dimensional model, and then to model the dynamics of the glacier and evolution. In the Alps, we performed this kind of modelization, and according to our model, for example, in the Italian Alps, glaciers could be close to the extinction in 2060. That is to say that more or less the 80% of the present glacier extent could be disappeared, okay? If the increasing, the air temperature will increase at the same rate, and also with the darkening effect, this is affecting all our glaciers. So for the Alps, we have more information, but in particular, more information on ice thickness and three-dimensional geometry of glacier. In Egmont in Asia, we have some sparse information and data, but we need to make a stronger campaign, field campaign, geophysical campaign in particular.
Thank you, Adele.
Just a word concerning the absorbing component of the atmospheric aerosol. We definitely found in special events, special acute events, impressive quantities of equivalent black carbon at very high altitude, so at 5,000 meters. And considering this amount of aerosols and the deposition on glaciers, we derived an increase of water melting of 24% on a typical Tibetan glacier. So this also is an additional point to be considered.
Okay. I think we have another intervention there.
Okay, thank you, Chairman. So, and also to thank all the experts for their excellent presentations. I'm from the CMA, so I want to, by the chance, to introduce our activities about the third pole, I think. So, a little times. So, we think the third pole is the largest cryosphere reservoir outside the polar areas and the critical water resource for Asia. So I think it is very important. So the CMA also places high importance on climate change research and related work in the third pole region. So maybe rely on the following serial satellite, we has constructed a long-term satellite remote sensing data set for the third pole. So maybe covering the products such as snow cover, plateau vortex, and the cloud the classification. And these satellite products have enriched the regional monitoring capabilities and provide the solid support for the research and climate change response. So as one of the WMO's strategic priority areas, the WMO is committed to the strengthening the cryosphere and the infrastructure system and the service capabilities. China actively the participants in the development of the global cryosphere watch and undertakes the responsibilities of the northern node of the WMO third pole regional climate center network, and serves as the overall coordinating node to promote the development of service functions within network. Meanwhile, China is actively advanced the third pole climate forum and flagship initiative that supports the countries surrounding the third pole in jointly addressing cryosphere-related disaster risk and caused by the rapid changes in this region. So, and I think finally, under the framework of WMO, we're willing to deepen cooperation with all members and relevant organizations, continuously advance third pole cryosphere observation, research, and service, and jointly contribute to the addressing the severe impacts of climate change and achieving the regional sustainable development. Thank you for all.
Thank you for your statement. So, we have another intervention.
Thank you so much. First of all, allow me to congratulate for your excellent presentation and the entire activity. But as my previous colleague, please do in the future to connect to the operations, because without operation, it's pity that you preserve only for research. Yes, research is very important in the context of climate change and future scenarios, but a lot and all meteorological and hydrological services and state members within WMO need to use this information also for the forecasting and warnings, especially due to avalanche. Also in Romania, we have a component and department that work on this, but in operation, it's pity, because your excellent work must be also useful for the operation. Thank you so much. Congratulations once again.
Thank you, Elena. Yes, of course, services and products are of utmost importance beside the scientific research. You're right. Okay, to conclude, I highlight the sense of proud I feel by bringing here my colleagues from Italy, and I want to congratulate them. And in doing so, I want to congratulate, let me say, the testimonial of those activities, who is an old Italian climber, Agostino da Polenza, who is sitting there, and he went on K2 last summer on the occasion of the 70th anniversary of the first climb. He was there with 7 Pakistani female climbers and 7 Italian female climbers on the K2. Thank you, Agostino.
You are aware that I'm a diplomat, not a scientist, even less a meteorologist, but let me express once again my gratitude for Generale Baione for organizing this event and for inviting me. I mean, we live in a time in which science and multilateralism are both under strong criticism, and it's not a case that the two go together, because science is by definition universal, like the multilateral system. So I think there is a common responsibility in raising again the awareness that we need international cooperation to face challenges like the climate change and specific issues like the cryosphere and the glacier. So in our beautiful mother tongue, the word tempo has 2 meanings. One is weather, and the other is time. And it's now, I think, time to have a drink.